Hey guys, good evening everyone. Good evening the space achievers. Good evening all the ISRO 2023 aspirants. And yes, we bring to you the space achiever series. Yes, that is the most expected questions as per the ISRO standards, as per what has been asked in ISRO for the past years, what is the level, and to match up with that and to give you the relevant problem practice, we bring you to this series, the space achievers. That is the most expected questions. The most expected questions. And yes, we are going to have a discussion of digital electronics questions again, as I told you, in parallel with EMFT. This two subjects like digital and EMFT, if we talk about the weightage of ISRO, especially for electronics, is the highest weightage, you can say, EMFT as well as the digital electronics. Okay, and as you all know, whether it is, okay, of course, highest weightage, higher weightage is a good thing, but whether it is ISRO or GATE or ESE, digital electronics should always be scoring for the students, right? So let's get started, guys. Okay, this is a intro about me that you're already aware about. Let's move ahead, and guys, let's trick it. Yes, guys, the Trickopedia. Okay, a dictionary of tricks. A dictionary of tricks. Okay, live. Okay, every day for you. Okay, small tricks, small approaches of the question, so that every trick and every approach can fetch you maybe 1 or 2 marks in the real GATE examination. Yes, so we need to know quick approaches, smart approaches to solve the question. So for EECCS, starting from 15 June, stay subscribed to the channel, and in case you have not subscribed, do subscribe it not, because several such great things are going to come up for you. The Trickopedia. Okay, also guys, today 6 June, okay, that is just at 7:30 p.m. on the BYJU'S exam prep app. Okay, Dheeraj Sardana sir, more than 10 years of teaching experience, going to bring you a free workshop, and he's going to talk about how to secure rank under 100 in the upcoming GATE 2024 examination. In the upcoming GATE 2024 examination, right guys? Okay, also guys, other than this, as I told you, electromagnetics is also a high weighted subject in ISRO. So okay, today in this particular session you will get all digital electronics question, most expected questions, but again electromagnetic students little bit more support. Okay, and to support you in that EMT preparation also, again on the app under the free classes, there are classes going on for the ISRO score booster, and where, okay, this particular Monday to Friday, that is 5th to 9 June, I am having the classes daily at 11 a.m. Okay, and if you talk about tomorrow we'll have the class with respect to the wave propagation. So daily one class is going on the app to you boost up your performance in EMFT. You can join here as well. This is going to be on the app. Okay, right. And for GATE 2024 aspirants, guys, stay tuned. Friday 10 p.m. the complete 8 months roadmap. The complete 8 months roadmap to secure rank under 100 in GATE. Okay, this Friday 10 p.m. on this same YouTube channel. And now let's get started with the question, guys, quickly. Now let us get started with the questions. Have a look into this question. The Boolean expression for the shaded region as shown in the figure. Well, it's a logical question. Okay, you don't have to solve anything. It's a logical based question, right? Very good evening all. Keep joining and share the session to all your friends. Just a moment. Okay, yeah, tell me the answer then. It's a very pretty logical question that you're able to feel that the shaded portion. So like if you talk about this particular portion, what is this particular portion? This is the portion which only belongs to X. There is no Y, there is no Z, means I have eliminated the common area. Okay, so that means this is the portion only with X. So only with X means there is no Y and there is no Z. Y is not there, Z is not there, only X is there. So X, Y bar and Z bar. Okay, similarly, this is the portion for only Y and this is the portion for only Z. Only X, only Y, only Z, and correspondingly, the answer is C. This is only Z, this is only X, and this is only Y. Right, and correspondingly, the answer is B. Got this? It's a logical question. It's a logical, converting the Venn diagram into the Boolean function. Converting the Venn diagram into the Boolean function. Moving ahead. The circuit shown realizes what function? The circuit shown realizes what function? Okay, a basic Boolean function based question. A basic Boolean function based question based on logic gates. Based on logic gates. It realizes what function? Come on, let's do it up quickly, guys. Okay, let's do it up quickly. So what do I see here is, of course, Okay, this is the output of the NOR gate A plus B whole bar, and this is the output of the NAND gate CD whole bar, and then again it goes to the NOR gate. Now the interesting thing is, okay, this NOR gate output, okay, let's say this particular NOR gate output is X, which can be computed, but I don't want to compute it right now. Why? Because if this is X, look into this. This X goes to this NAND gate with the input E. So what is the output of this NAND gate? The output of this NAND gate is XE whole bar. XE whole bar. Okay, now this XE whole bar along with the X again goes to the NOR gate finally. So how do you write down the output of NOR gate? How do you write down the output of NOR gate? A plus B whole bar. That means X plus XE bar and whole bar. A plus B whole bar. A plus B whole bar. Okay. Now this should be equal to what? X plus XE whole bar. XE whole bar will be X bar plus E bar. XE whole bar will be the X bar plus E bar. Right. And then whole bar. And Asham, just recheck here. Am I correct? X plus XE whole bar. Now what is XE whole bar? Again you can open this by the De Morgan's law. Na? A into B whole bar is A bar plus B bar. Okay, similarly this is X bar plus E bar. Now X bar is going to be added with X. X bar is going to be added with X. Right. So that becomes 1. Right. 1 plus anything is 1 and 1 ka complement should be the 0. Isn't it, guys? Isn't it? Right. Correct answer is option number. Where is that? Sorry. Oh. Yeah, let's move ahead. So correct answer is none of the above. Very good. The correct answer being none of the above. Just a second. Why it is not getting maximized? Just 1 second, guys. There is some trouble that I am facing here. Anyways, there is some trouble that I am facing. I am not able to see its buttons. Okay, let's move ahead then. Let's move ahead to the next question. What is the issue happened? Yeah, that's fine now. Okay, so yeah, correct answer is none of the above. Okay. It's none of the above. Let's check it out. Okay, it's simple logic that if I figure it out from here, then the answer becomes simple. Next question, guys. Okay, consider the circuit shown below, which is a circuit built using a decoder, a 3x8 decoder, and the function can be expressed in the minterm list or the maximum list. Which of the option is correct? Which of the option is correct? Have a look into this and let's try to answer. Okay, the minterm list or the maximum list. Minterm list or the maximum list. चलो चलते हैं आगे की तरफ. Okay, the minterm list or the maximum list. Okay, now this is a NOR gate. Okay, this is the NOR gate, and which is taking the inputs from D1, D2, D4 and D6. Now output of a decoder is what? The output of a decoder contains of the minterm. So I have the minterm number 1, minterm number 2, minterm number 4, minterm number 6. Okay, first let us treat the OR functionality. The OR functionality is adding summation of M. What? 1 and 2 and 4 and 6. And then because it is the NOR gate, you will put the whole complement on this. Clear? You will put the whole complement on this. Now this question, in the role of decoder in this question is just to read up the minterms. Rest is basic Boolean and minterm knowledge. Okay. And such also logical and property based questions are definitely expected for these examination ISRO. ओके अब देखें समेशन है 1 to 4 6 का होल बार. ओके नाउ व्हाट इज समेशन है 1 to 4 6 का होल बार? द कॉम्प्लीमेंट विल कंटेन द मिन टर्म्स व्हिच आर नॉट इंक्लूडेड इन द गिवन फंक्शन. ओके दैट मींस दिस मस्ट बी इक्वल टू समेशन ऑफ व्हाट मिन टर्म्स 0 and 3 and 5 and 7. ठीक है 0 3 5 7 and I don't know what are the options right now, but it is also equal to, if you want to express in the max term, let me tell you, if you want to express in the max term will contain those numbers which is not in the min term list, means it will again contain 1 2 4 6, right? So either C, which is the option correct? If you talk about 0 3 5 7 max term list, C is correct. Min term list mein likhna hai to it should be 1 2 4 6. No, this is wrong. So the correct answer is C here. The correct answer is C. Right everybody, the final correct answer for the question is equal to C. Everybody. Next question. Moving ahead to the next question. The figure shows a 4:1 mux to be used to implement the function f(abc) equal to summation m1 to 4 6. Which of the following combination of input to I0, I1, I2, I3 of the mux will realize the function? Implementation of Boolean function using multiplexer where the select lines are AC. इसको ध्यान रखना. The select lines are AC. And if the select lines are EC, okay, if the select lines are AC, okay, ध्यान देना, A, B, C are the 3 bits, okay, A, B, C are the 3 bits and that can have 8 combinations, 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. Out of which I am telling you that A and C are known as the select lines here. A and B are fed to the select lines. Right. So what goes to the data line? What goes to the input line? What goes to the data line is the variable B. Okay, is the variable B. Now, to implement this, we need the implementation table. The shortcut method for this, to implement any Boolean function using multiplexer, is the implementation table. Now, what is the general nature of implementation table? This implementation table will have 4 columns corresponding to the 4 input lines, I0, I1, I2, I3. If it is a 8 cross 1 mux, 8 input lines are there, so I will have 8 columns, right? So I0, I1, I2, I3, 4 columns will be there. The same implementation table will also have 2 rows. Okay, 2 rows corresponding to what? Corresponding to the variable that you have to see, that is going to go to the input line. So AC to select line, B goes to the input line. So make 2 rows, one for the complement, one for the true. So I will write down B bar here and I will write down B here. Now, what are the numbers that you will write in the row of B bar? In the row of B bar. So when do you write B bar as per the Boolean laws, as per the min-term laws? We write down B bar when the B is 0. So where is the B 0? The first 2 min-terms pe aa jayenge, that is 0 and 1 and then 4 and 5. Rest, this is B1 and this is B1. Okay. So where is B1? Min-term 2, 3. 0, 1, 0 is 2, 0, 1, 1 is 3. And then 1, 1, 0, 6, 1, 1, 1, 7. So that is 2, 3, 6, 7. This is the implementation table. How to make implementation table I explained. Now look into the function given. Function is summation m1 to 4 6. Okay. Function summation m1 to 4 6. Okay. So whatever are the given min-terms of the function, highlight them. Okay. 1, 2, 4, 6. Highlight the given min-terms of the function in the implementation table and now do the column by column analysis. Okay, in the first column, okay, second row, that is B. In the second column, the circle is corresponding to first row. First row kya hai? B bar. In the third column, the circles are corresponding to both the rows. Now, what is the meaning of both the rows? B bar is also available, B is available. So, what is B bar plus B? What is B bar plus B? It is 1. That means if both are circled, write down 1. And in the last row, last column, no, none of them is circled. So write down 0. Okay. Last mein 0. So your answer should be B, B bar 1, 0. The inputs to be applied to the multiplexer is here B, B bar 1, 0. B, B bar 1, 0. B, B bar 1, 0. That is the inputs to be applied to the multiplexer. That is the inputs to be applied to the multiplexer. Right, sir? Moving ahead to the next. In a ripple counter, a fundamental question you must know, in a ripple counter using edge-triggered JK flip-flops, The pulse input. A pulse input, of course, means the clock pulse input is applied where? The clock pulse input is applied to what? In a ripple counter using edge-triggered JK flip-flops, the pulse input is applied to the clock input is applied to, okay. Is it applied to clock input of all flip-flops or the clock input of only one flip-flop? It is applied to the clock input of only the one flip-flop, okay, and that is the LSB flip-flop. Which one flip-flop? The LSB flip-flop. The clock is applied to the LSB flip-flop and then output of every flip-flop, ripple counter you must know na, output of every flip-flop will serve as clock to the next flip-flop. The output of every flip-flop will serve as the clock to the next flip-flop. Okay. When you apply the pulse input to the clock input of all the inputs, that become a synchronous counter actually. The option number A is for synchronous counter, not for ripple counter. Right. Acha. One more thing in ripple counter, what about the JK input? This is about clocking. What about the JK inputs? Okay, so I told you the clock input is applied to LSB flip-flop and output of every flip-flop will serve as the clock of the next flip-flop. And one more thing, okay, and one more thing with respect to the ripple counter, that all flip-flops are in the toggle mode, right? All flip-flops are in toggle mode. Toggle mode means, what is the toggle mode of JK flip-flop? So this question is talking about JK flip-flops, right? So JK flip-flop, J and K are both equal to 1. That is the toggle mode. Because when JK are both equal to 1, the output will toggle, the output will complement. All flip-flops are in the toggle mode. Correct, sir? PDF, Prashant, you will get it in the Telegram group. You will get it in my Telegram group. Okay. Chalo, let's move ahead to the next. Like maths ISRO session also, which I took, that PDF was also shared in the Telegram. You will get it in the same in my Telegram group. Let's move ahead to the next question. Right, have a look into this. The output frequency in kilohertz if a 6 megahertz clock frequency is applied to a cascaded counter of modulus 2 and modulus 3. Output frequency in general would refer to the MSB frequency, and now there is a cascade combination of, there is a cascaded counter of modulus 2 and modulus 3. So whenever counters are connected in cascade, the mod numbers are multiplied. The mod numbers are multiplied. Okay, so here the obtained counter, which is the cascade of mod 2 and mod 3 counter, will have mod 6. Okay, will have mod 6. Okay, so I will be having a mod 6 counter. I will be having a mod 6 counter. Now, what is the output frequency, dear? What is the output frequency? Now, output frequency or MSB frequency is given by the clock frequency divided by the modulus number. So what is the clock frequency given? 6 megahertz divided by mod number is 6. So answer is 1 megahertz, right? 1 megahertz. Okay, they are expecting the answer in kilohertz, so no problem. 1 megahertz is 1000 kilohertz. We can split that. Now megahertz is 10 power 6, so 1000 into 10 power 3, 1000 kilohertz, option number B. It is a 1000 kilohertz, that is the option number B. Okay, moving ahead to the next. For a mod 10 counter, Johnson counter uses X flip-flops, ring counter uses Y flip-flops, and ripple counter uses Z flip-flops. What is X plus Y plus Z? For a mod 10 counter, okay, now this again a fundamental question that you must be able to solve. Okay, now Johnson counter uses X flip-flops. Okay, if it is a n-bit Johnson counter, what is its mod number you try to recall? Okay. For a n-bit Johnson counter, it can generate 2 n states. For a n-bit ring counter, it can generate n states. So for a mod 10 counter, if you want to use Johnson counter, it should be having 5 bits, right? So 5 flip-flops. Ring counter, if you want to design a mod 10 ring counter, it should have 10 bits. That means 10 flip-flops. So X और Y का value दे आ गया. Ripple counter की बात करते हैं. Ripple counter Z. For a mod 10 counter, a regular ripple counter, how many flip-flops are required? How many bits are required to represent values up to 9? Mod 10 means suppose 0 to 9. Okay, can you do it with 3 bits? 3 bits can represent 0 to 7. 3 bits can represent 0 to 7 maximum. 8 combinations can be there for 3 bits. So you need definitely 4. You need definitely 4. Okay? You definitely need 4. Because 3 bits can only represent up to mod 8. Okay, so you need 4. Okay, so answer for x plus y plus z is 19. 5 plus 10 plus 4, correct answer is 19. Acha, how to obtain this 4? If in case you are confused, you can also note down. Here it is mod 10, we can logically think. In general, it can be obtained by log of 10 to the base 2 with the ceiling. That is the upper integer. Okay, log of 10 to the base 2. Okay, mod number 10 is the mod number and 2 is the base because we are dealing in binary. Okay, if you calculate this value, na, chalo calculate करके बताता हूँ मैं. Just a second. So if we calculate this value, okay, that will be 3.32. Okay, so you can split this. Log of 10 to the base 2 is log 10 divided by log 2, and this is turning out to be how much? 3.32. And then I have taken the ceiling. Ceiling means what? The integer above. Ceiling is something above me. So what is the integer above 3.32? That is equal to 4. See, I'm telling you, 10 is a small number. You can still deal with it. But otherwise, in general, you can use the log if you are sometimes confused. Okay, done. So answer is 19. Okay. But yeah, such questions you must know. Okay. Next आ जाते हैं. A binary ripple counter is required to count up to 16,383. Up to 16,383. How many flip-flops are required? Again, by intuition. By that method, by intuition, like I solved, 10 means 3 bit to nahi hoga, 4 bits required hoga. See, very clearly, you can, answer at least up to A and B. What is 2 power 8? What is 2 power 8? It is 256. And what is 2 power 10? It is 1024. Okay, it is 1024. Okay. So this can only count, 256 is the total count, means 0 to 255. 256 means the counter can be 0 to 255 if I start from 0. Okay. 1024 means the counter states can be 0 to 1023 if I am starting from 0. So definitely these two are not possible. 2 power 14. See, if you want to do it without calculator. Okay, if you want to do it without calculator, yes, you must be able to do it without calculator looking into ISRO. Okay, looking into ISRO. Okay, so that is 2 power 4 is multiplied by 2 power 10. The 14 can be split as power 4 and 10. Now 2 power 4 is 16 multiplied by 1024. So yeah, this is clearly looking like that will go in the 16,000 range. That will go in the 16,000 range. Okay, so definitely 24 into 16 आपको करना है. Rest is 16,000 something. So 24 into 10 240 into 5 भी किया तो 360 plus 16 378. Sorry, 360 तक आ गया था. 384 24 ऐड करना था. Sorry, 384. Okay. Now, if it is having the mod number of 16384 means it will count from 0 to 16383. That is what I want. That is what I want. So correct answer is C. Correct answer is C. Again, I'm telling you, if I had the calculator, what I can do? If I had the calculator, what I can do? Okay, what I can do? Okay. If I had the calculator, I can calculate the value of 16,384 ka log divided by log of 2. Why 384? Because it is counting up to 383. But the counting always starts from 0. So total number of count becomes 384, 16,384. And once again, now this is applicable if you have the calculator. So I'm telling you with that angle also. Okay. When I divide it by log 2, I am getting exactly 14. I am getting exactly 14. 14 is an integer, so no need to take the ceiling part. Directly I am getting it as 14. Okay. But this is what, even without calculator like ISRO, you can be able to deal with the calculation because it's a simple one. The correct answer is C. Okay. Correct answer is C. Again, a logical question based on the counting. Yeah, good question. Again, based on flip-flop. Although again, fundamental. But yeah, design AB flip-flop. So the truth table for an AB flip-flop is shown below. If this flip-flop is designed using JK flip-flop, if this flip-flop is designed using JK flip-flop, complete कर देते हैं statement को. If this flip-flop is designed using the JK flip-flop, then what is the input to the JK flip-flop? Then sir, what is the input to the JK flip-flop? If this flip-flop is to be designed using the JK flip-flop, what is the input to the JK flip-flop? Okay, chalo. Okay, so have a look into this. AB QN plus 1. Okay, if this flip-flop is to be designed using JK flip-flop, then what is the input to the JK flip-flop? Okay, now what you have to think is ultimately this has to be designed using JK flip-flop. So to achieve the QN plus 1, so to achieve the given next state, what should be the JK input? So I'll just take this table here once again and I will add the column for J and K separately. And let me make these entries. Okay. Now the required Qn plus 1 is 1. Qn plus 1 is equal to 1. 1 bole to set, and the JK flip-flop is set whenever you put J equal to 1, K equal to 0. Next, Qn plus 1 equal to Qn, matlab no change, same state. So the JK flip-flop remains in the same state whenever both the inputs are 0. J0, K0. Next, Qn plus 1 equal to Qn bar. Qn bar is toggle. So the next state is toggle if both the JK inputs are 1, 1. If both the inputs are 1, 1. Qn plus 1 equal to 1, that means the flip-flop is reset. That means the flip-flop is reset. Qn plus 1 equal to 0, flip-flop is reset. Okay, and the flip-flop is reset whenever J is 0, K is 1. Okay, now this AB flip-flop has to be designed using JK flip-flop. Okay, has to be designed using JK flip-flop. What should be the input to the JK flip-flop in terms of A and B very clearly? Okay, in terms of A and B. So now what you have to do, take this as an input. You have to suppose design the circuit, okay, where the AB should be the input and JK should be the output. So what is J and K equal to? Dekh lete hain yahan pe. What is J and K equal to? The J in terms of AB. In terms of AB, dekho J is high at the first and third. That is 0, 0 and 1, 0. 0, 0 corresponds to A bar, B bar. Plus 1, 0, that is A, B bar. So what will happen here? B bar is the common and then you are left with A bar plus A, and that is going to be 1. So J is equal to how much? B bar. Okay. If you talk for K, right, K is high at the last two combination. 1, 0, that is A, B bar. Plus 1, 1, that is A, B. Right. So what is the K equal to? That is equal to A. B bar plus B will be 1. So K will be equal to A. J will be B bar, K will be A. Okay. J will be B bar, K will be A. The J will be the B bar and the K will be the A. Correct answer is option number B. J equal to B bar, K equal to A. J equal to B bar, K equal to A is the very correct answer, dear. Okay, done. Let's move ahead to the next question. Okay, the initial state is 100. The initial state is 100. Find the mod number of the above of the below counter. Find the mod number of the below counter where the initial state is 100. Where the initial state is 100. Let's have a look into this. Okay. Find the mod number of the counter. So how to find out the mod number of this particular counter? Let's have a check and let's have a look into this. Kaise karenge? Okay, it's definitely, see, if you look into these equations, let me write them here. If you look into these equations, okay, what is going to be Q1 plus? Okay, what is going to be the Q1 plus? The input to any D flip-flop is equal to the D. The output of any D flip-flop is equal to its D input. Q plus equal to D. So Q1 plus equal to D1. But what is the D1? The D1 is actually connected to Q2. Okay. Also, at the same time, what is Q0 plus? That is D0. But where is D0 connected from? D0 is connected from the Q1. Is connected from the Q1. Okay. Now, if I just make this table, that is Q2, that is Q1, and that is the Q0. The Q2, Q1 and Q0. Very clearly, the first thing that you should be able to understand is, The first thing is you have to understand is Q1 plus is Q2. Matlab whatever Q2 current value, that will become the next state of Q1, Q1 plus. Okay, that should come here. Whatever is the value, that should come here. Similarly, Q1 is Q0 plus. Matlab whatever is the current value of Q1 will go to the next value of Q0. So it is nothing but a right register, right shift register. This circuit is nothing but a right shift register, dear. It is a right shift register. It is known as the right shift register. Done? It is known as the right shift register. Okay. Right. And the initial state is 100, and because of the right shift, what will happen? The first two bits are transferred to the next, that is 10. Okay. First two bits ko right shift kar diya 10. But what will come to the MSB then? What will come to the MSB? Yahan pe dekhenge hum. So what is the value of the Q2 plus? The Q2 plus is equal to D2, and D2 is equal to, we call this input as the serial input. And what is that serial input here? Serial input is obtained from the input from the output of a 3-input XOR gate, and XOR of all the flip-flop, all the 3 flip-flop outputs. So this is known as XOR of Q2, Q1 and Q0. XOR of Q2, Q1 and Q0. So what is the serial input? Let us write down the serial input column separately. Right. Now XOR output, 3-input XOR, multi-input XOR. XOR produces high output whenever the input string contains odd number of ones. So look into this. How many ones are available in the input? Okay. How many available in ones? 1. How many ones? 1. 1 is an odd number? Yes. So XOR output high. Now whatever is the serial input, that will become the Q2 plus. That will be the next state here. So this goes here, this goes here, this goes here. Okay. Now next. Okay, next. The first two bits shift right. What will come to the MSB? So take the XOR of 110. What is the XOR of 110? How many ones? 2 ones. 2 is an even number. The XOR output 0. Okay, so 0 यहाँ पे आ जाएगा. ठीक है. Now take the 011. How many ones? 2 ones. The XOR output 0. Okay, now first two bits shift right 01. And this serial input slide in. Now 001. 001. How many ones? 1. 1 is an odd number. Yes. So XOR output high. Now first two bits shift right. Okay, and then 1, it comes inside. I get what? I get 100. 100 means repetition occurs. Okay, we have to stop. Okay, because it will keep recycling now. ठीक है जी. So 100, 110, 011, 001. Okay, so how many different states? ठीक है, 100 तो repeat हुआ. How many different states? 4. It is a mod 4 counter. Correct? Mod 4 counter. And we have the option, yes, correct answer is option number A. It is a mod 4 counter. Done hai? Chalo. Mod 4 counter. Moving ahead to the next. Okay. Consider the partial implementation of a qubit counter. Using T flip-flop following the sequence 0, 1, 4, 6, 5 as shown below. To complete the circuit, input X should be how much? To complete the circuit, input X should be how much? To complete the circuit, input X should be how much? Now, this is like designing. Okay, where one of the inputs, we can actually calculate inputs of all flip-flop to understand this. Now, partial implementation is given, and what is the sequence I need to follow? 0, 1, 4, 6, 5. Let us write down this particular sequence here. Okay, Okay, so the outputs of the flip-flops are Q3, Q2 and Q1. Okay. This is Q3, this is Q2, this is Q1. Okay. So the current state. To design any counter, we need to write down the first of all current state and the next state relation. Current state and next state. What is the current state? Let us write this as Q3, Q2, Q1. What is the next state? Q3 plus, Q2 plus, Q1 plus. Okay, ji. So current state and next state, and with respect to that I will write down the excitation table, excitation signal. That means what should be the input to the T flip-flop, okay, to make this state transition occurs. Usually input of a T flip-flop is then given and you are able to find the next state. You are able to find the next state. Okay, you are able to find the next state. Okay, but here I will give you the current state and next state, and to obtain the next state what should be the T input, ये हमें decide करना होगा. That is what we are going to design actually. That is what we are going to design. So what is Q3, Q2, Q1? What is Q3, Q2, Q1? इसको देखना पड़ेगा. So we have 0, 1, 4, 6, 5. We have 0, 1, 4, 6, 5. Okay, so 0, then 1, then 4, then 6, and then 5. Okay, and then 5. Okay, this is what, let me write down the numbers here. 0, 1, 4, 6, 5. This is the state sequence we want. That means whenever the current state is 0, next is 0, 0, 1. So for 0, 0, 0, next is 0, 0, 1. For 0, 0, 1, what is the next? 1, 0, 0. So I'll write down. Okay, similarly for 1, 0, 0, next is 1, 1, 0. For 1, 1, 0, next is 1, 0, 1. And for 1, 0, 1, next is 0, 0, 0. Next is 0, 0, 0. Okay, now listen to me. Okay, we can complete the excitation table now. Look into this Q3. First, let's start with Q3. For Q3, what is the change? In the first row, what is the change? 0 to 0. 0 to 0 means no change. Okay, no change means what is the T input? 0. Because whenever T input is 1, toggle should happen. Right? If you don't want the toggle, you should write T equal to 0. Similarly, next bit ko dekhenge. Let's complete the Q3 transitions. 0 to 1, it is a toggle. And it can only toggle if the T input here is 1. So T3 will be 1, then Q3 will become Q3. Q3 plus will be Q3 bar. Right? So 0 ka bar 1. Got this? That is how we have to deal with this. Okay, next. 1 and 1, same. Next, 1 and 1, again same. Next, 1 to 0, toggle. So what is the combination we saw? Same, same, toggle. Same is 0, toggle is 1. Okay. Similarly, let's come to the Q2. 0 ka 0, same. 0 to 0, again same. 0 to 1, toggle. 1 to 0, toggle. 0 to 0, again same. Complete. This is the T2 column. Let's go to T1. 0 to 1, toggle. 1 to 0, toggle. 0 to 0, sir, same. 0 to 1, sir, toggle. 1 to 0, again toggle. Okay. What is the question? We want, in the question, we want the input X. Input X, okay, which is going to the T1 input, the T2 input, sorry. Okay. This is going to the T2 input. So T2 input means X. Means X. That is what we need to figure out. Okay. So what is the X or T2? Okay. What is the X that is equal to T2 and that is high at these two input combinations 100, 110. 100 is 4, 110 is 6. Okay. So, okay, we need to write down this as a function of the input. What is the input? The current state, that is Q3, Q2, Q1, Q3, Q2, Q1, and that is summation of minterms. It is high at the minterms 4 and 6. It is high at the minterms 4 and 6. But this is not complete. Because I have, if I take the current state as the input, I have total 3 inputs, and corresponding to the 3 inputs, there must be 8 possible combinations. I have written only 1, 2, 3, 4, 5 possible combinations. 3 combinations are missing. What are those 3 combinations? Okay, what are those 3 combinations? Because 0 aa gaya, 1 aa gaya, 2 is missing, 3 is missing, 4, 5, 6, 7 is missing. Okay, these are missing. That means these are those input combinations which do not occur. And for the inputs which do not occur, for them the output is taken as don't care. So there will be a don't care list also. What are the input combinations that will go to don't care condition? 2, 3 and 7. that is important to solve the K-map condition. And now let's feed this into the K-map. It is not necessary that don't cares have to be used. If they help you in simplifying, please use them. Okay, I have the input as Q3, Q2, Q1 here लिख देंगे. So this will go to Q3. K-map भी आ गया यहाँ पे Q2, and this, let's say this is Q1, and let me feed the inputs. What are the inputs? Okay, the function is high at 4 and 6, so this is 4, 6. But there are don't care conditions 2, 3, 7. So 0, 1, 2, 3, 4, 5, 6, 7. Don't care को भी mark कर दिया. Okay. Now, what you may be thinking, what is the temptation that may be coming into the mind? Ki, sir, okay, let me make this a quad. Let me make this a quad. I can use don't care as 1 because higher group, bigger group will reduce more variable. But stop here. What you have to think is, what about this minterm? What about this minterm? Okay, can it be clubbed? If it can be clubbed, it is only clubbed with the right one because the first and last columns are adjacent in the K-map. The first and last columns are adjacent. Also, these two have to be clubbed. And anyways, to support this, you have already used this minterm. So both the minterms are used. So do you need to use the quad now? Do you need to use the quad? It is not necessary to use don't care. Yeah, if these were ones, then definitely I will make the quad. But these are not ones, these are don't cares. You may use it, you may not use it as per your convenience. Clear? You may use it, you may not use it as per your convenience. Understand this. Understand this. Okay, so here it is not required. Okay, so only the grouping that is coming, it is corresponding to the row of Q3, and this is Q1, so it is outside Q1, so this is Q1 bar. Okay, so what is the answer? The X is equal to Q3 Q1 bar. The X is equal to the Q3 and Q1 bar. The X is equal to the Q3 and Q1 bar. Q3 Q1 bar, that is the option number B. Q3 Q1 bar, that is the option number B. Okay. Q3 and the Q1 bar. Okay, yeah. So these were the 11 most expected questions as per the ISRO frequency. Okay, see, there are several topics in digital, but this one session was about most expected question based on the previous year discussions, what type of topics and what level of questions they are asking more. Okay, guys, meet you on Friday as well, other than this ISRO series. Okay, so for all those who are Gate 24 or Gate 25 aspirants, the 8 months complete roadmap to secure rank under 100, Friday 10 p.m. Friday 10 p.m. we'll meet for this. And also guys, as I told you, electromagnetics is also having a very high weightage in the ISRO examination, and if you want to practice it, okay, you can join me daily at 11 a.m. on the BYJU'S exam prep app. You can join me daily 11 a.m. on the BYJU'S exam prep this Monday to Friday. Okay, where I can bring different revision and question practice sessions of EMFT, electrostats, magnetostats. Tomorrow is going to be wave propagation, then waveguides and antennas. Right? Okay, that's it from my side. Thank you. Stay safe and take care. Keep preparing hard for the ISRO examination and do your best. Keep preparing hard, keep practicing, keep giving tests.